Bismillah, welcome back to ThinkMath. In the previous lesson, we introduced the idea of a limit. Today, we go further. We learn how to find the limit of a function algebraically. 3 questions to answer today. First, how do you find the limit of a polynomial function? Second, how do you find the limit of a rational function? And third, what do you do when direct substitution gives 0 over 0? Let's start with the 3 key rules. Rule 1, and this is the most powerful shortcut in this lesson. If f of x is a polynomial function, then the limit as x approaches a is simply f of a. Just substitute directly. Rule 2, the limit of a constant is just that constant. No matter how x behaves, if the function always equals k, the limit equals k. Rule 3, the limit laws. If we know the limit of f equals L and the limit of g equals m, then the limit of a sum or a difference equals L plus or minus m. The limit of a product equals L times m. The limit of k times f equals k times L. The limit of f over g equals L over m, provided m is not 0. And the limit of f to the power of n equals L to the power n for positive integers n. These laws allow us to break complex limits into simple pieces. Now, the key theorem for dealing with 0 over 0. If f of x equals g of x for all values of x except at x equals a, and we know the limit of g as x approaches a equals L, then the limit of f as x approaches a is also L. In practice, this means when substitution gives 0 over 0, we factor the numerator and denominator, cancel the common factor, and then substitute. Find the limit as x approaches 0 of x squared plus 3x minus 2 plus 2x over x minus 1. This is a polynomial combined with a rational expression. At x equals 0, the denominator x minus 1 equals negative 1, not 0. So we can substitute directly. 0 squared plus 3 times 0 minus 2 plus 2 times 0 over 0 minus 1. 0 plus 0 minus 2 plus 0 equals negative 2. Example B. The limit as x approaches 4 of x squared minus 16 over x minus 4. Try substituting x equals 4, 16 minus 16 over 4 minus 4, 0 over 0. Indeterminate. We must factor. The numerator x squared minus 16 is a difference of squares. It factors as x minus 4 times x plus 4. Cancel the common factor x minus 4, leaving simply x plus 4. Now substitute 4 plus 4 equals 8. Example C. The limit as x approaches 2 of x cubed minus 8 over x squared minus 5x plus 6. Substituting x equals 2 gives 0 over 0. Indeterminate. The numerator x cubed minus 8 is a difference of cubes. It factors as x minus 2 times x squared plus 2x plus 4. The denominator x squared minus 5x plus 6 factors as x minus 2 times x minus 3. Cancel the common factor x minus 2. We are left with x squared plus 2x plus 4 over x minus 3. Now substitute x equals 2. 4 plus 4 plus 4 over 2 minus 3. That is 12 over negative 1 equals negative 12. Example D. The limit as x approaches 0 of x squared plus 2x over root of x plus 9 minus 3. Substituting x equals 0 gives 0 over 0, indeterminate. This time we can't factor directly because of the square root. Instead, we multiply numerator and denominator by the conjugate of the denominator. Root x plus 9 plus 3. The denominator becomes a difference of squares, x plus 9 minus 9, which is simply x. The numerator becomes x squared plus 2x times the conjugate. Factor out x from the numerator, x times x plus 2 times root x plus 9 plus 3. Cancel the x. Now substitute x equals 0. 0 plus 2 times root 9 plus 3. That is 2 times 6 equals 12. Now, a special type of question. Given that the limit as x approaches 3 of f of x minus 1 over x minus 3 equals 4, where f of x is a polynomial, find the limit of f of x as x approaches 3. As x approaches 3, the denominator approaches 0. For the overall limit to exist and equal 4, the numerator must also approach 0. So, f of 3 minus 1 equals 0, which gives f of 3 equals 1. Since f of x is a polynomial, the limit of f as x approaches 3 is simply f of 3, which equals 1. Now, let's practice. Try each of these before looking at the answer. The limit as x approaches 2 of x squared plus 3 times x cubed minus 2x squared plus 4x minus 1. Both factors are polynomials. Substitute directly. 4 plus 3 equals 7. 8 minus 8 plus 8 minus 1 equals 7. 7 times 7 equals 49. Next, the limit as x approaches negative 1 of 2x plus 3 squared minus 1 over x squared plus x. 0 over 0, factor, numerator, 2x plus 2 times 2x plus 4. That is 2 times x plus 1 times 2 times x plus 2. Denominator, x times x plus 1, cancel x plus 1, substitute x equals negative 1. 4 times 1 over negative 1 equals negative 4. Next question. The limit as x approaches negative 2x minus 3 over x squared plus 1. Denominator at x equals negative 2. 4 plus 1 equals 5, not 0. Substitute directly. Negative 2 minus 3 over 5 equals negative 1. And that is how we find limits algebraically. The three methods are direct substitution for polynomials, factor and cancel for 0 over 0, and rationalization for square root forms. Follow ThinkMath for more IB, A-Level, AP, and IGCSE mathematics. Links are below. See you in the next lesson.